And I'm sorry, not conic sections, piecewise functions.
Okay, they're very different. So hopefully you do mean piecewise functions.
Yeah, I'm sorry, I'm fine on conic sections. That's the one that I was good on. So I don't need that.
Okay, because piecewise functions are a lot more straightforward than conic sections. Are you graphing these? What else? What do you have going on with these?
We're graphing them, and we have to like they give us a graph, and then we have to like write out what the equation is.
And backwards. Okay. Okay. Yeah. Anything else on that list?
Where is it? It was. Oh. It was logarithms. I know that. Hold on, I'm looking through my math book.
Okay.
Oh, and then it's converting logarithm problems.
Okay. It would help to have an example of this.
Yeah, I can send a picture through the email.
Okay, that'd be great. You can send me by email pictures, documents you want to share, PDF files, whatever you need to, and you can always redirect me at any time. So we're recording this screen sharing session, and I'll send you a PDF copy of the notes in an email later today. Hopefully that does not go to your spam as well. So if you're ready, we can get started and talk about some piecewise functions. Are you ready to start on that? Let's see, maybe you're muted. Nope. Okay. I'm gonna assume you're ready. Are you what math class are you currently taking?
It's pre-algebra. I know that, but like my book is Saxon.
Okay.
Advanced mathematics and incremental development.
Yeah. Okay. So I'm finding some other resources for us to work on rather than just making them up here. So let's snip in. If you're seeing my screen, you're seeing a piecewise function here. The first part, it's defined when x is less than or equal to 2. The next part's defined when x is greater than 2. To evaluate each of these, a, b, c, d, at 0, 5, 2, and -3, you have to decide which is true. Only one of these is going to be true in terms of like, is 0 less than or equal to 2? And the answer is yes. Yes, that's true. So you evaluate it in this top one. We're going to do some graphing, but this is normally where it starts. So I'm just going to start here. This becomes -1. Then about 5, we say, is 5 less than or equal to 2? The answer is no. So you do know that because if one is true, then the other must be false. If the first one is false, the next one must be true. Is 5 greater than 2? Yes. So we put that into the second one. 4/5 times 5 minus 4. And that reduces to 4 minus 4, which is 0. 2, is 2 less than or equal to 2? Yes. Okay, because it's equal there. So we're going to evaluate it at the first part. 2 times 2 squared minus 1. So this is -8 minus 1, which is -9. Is -3 less than or equal to -2? Yes. So we evaluated in the first one. -2 times -3 squared minus 1. This is -18 minus 1 -19. And again, I'll just repeat that you do get, I will send you a copy of this at the end. So if this seems difficult or it wasn't clear, I can do more examples as well. One of the limitations of this format is can't really read your body language. So if you have to tell me, hey, Matthew, I didn't understand that, or if you want, you can send me a chat message or just interrupt me. But the last thing I want to do is go too fast or not give you enough examples of what you want to see. So this is another example of piecewise function. I know you said you want to do some graphing, but you could be given a graph. This is given a graph. Can you evaluate at various points? So -1 here, this means go to where x is -1, which is right here. And what's the y value? Y value is 0. So this right here is the x value. In parentheses is the x value, and the y value is what we're trying to find. So f of 2, that means, okay, where's 2? Right there. What's the y value there? The y value there is 1. At 1, can you tell me what the y value is here at 1? Didn't hear you, but I'm assuming you said 1. Okay, great. All right. Now, f of -2 is over here. That's -1. F of 0 is 1. So let's try to do what you had originally asked, which is, can we create a piecewise function from this graph? How many pieces do you see for this graph?
3.
3. There's 3 pieces. Okay, and so we divide them up here. We got 1, 2, and then 3. So what's usually easier is to do the intervals first. Like this line here is good for x less than -2. Why is it less than and not less than or equal to? It has to do with this right here.
That's the open circle.
Open circle, right? Okay, and then the next one, it's between -2. We're looking at the x values all the way to 1, but it does not include 1. So that's why it's an open circle there. And then the last one is x greater than or equal to 1 because it's a closed circle. So usually this is the easier part than the other one. I don't know, you can disagree if you want, but that I usually feel like these are more straightforward. The next thing we do is figure out, well, what is this? Well, this is a line. Okay, and there, we have to come up with the equation of a line. So a line is like y equals mx plus b. We need the slope and we need the b value. So the slope is, well, this one's not great. Let's assume, trying to decide if I think it goes through there. Let's assume it goes to this point here, -6, 0. And then this is -2, -3. The slope would be y2 minus y1 over x2 minus x1. So it'd be like -3 minus 0, -3 minus 0 over -2 minus a -6, -2 minus a -6. And that would be, that'd be like -3 over 4.
Okay.
Although that doesn't seem right, but we'll assume it is. Okay. So that's the slope. Now, how do we find the b value? Well, we got y equals -3/4 x plus b. To find the b value, just put one of these points in. So let's put this other one in. So y is 0, x is -6 plus b. And so b is, when we solve for this, so -3 times -6 is 18, 18 over 4 plus b. This is 9/2. Subtract to the other side, so b equals -9/2. So we have our equation. We have our slope, which is -3/4 x plus 9/2, and that works for this first one. The second one should be more straightforward. Okay, so this is, again, it's equation of a line. What's the slope of the line? Well, it's rise 1 over 1, rise 1 over 1. So we know its slope is 1. We don't have to make points because it works out really nicely. So we can just write 1x plus, where does it cross the y-axis? Right there at +1. And then the last one here, it's a line, but it's a straight line. What's the slope of a horizontal line?
0.
0. 0x plus, Well, we don't know where it crosses, but we can imagine it goes back. We can imagine that it would cross at 1. So if we were to clean this up just a tiny bit here, we wouldn't necessarily need that part. We would just get rid of it. Okay. Is that the type of problem you were trying to better understand?
Yes. Yes, those are.
Okay, let's do a couple more like that then, and see.
Yeah, I was absent the day. We learned it, and the book is not good at explaining things. So
yeah, it's a limitation of it. Okay, so let's look at another problem here, and this time we're not going to worry about evaluating it. We're just going to worry about writing the 3 equations. So to me, there's this region 1, region 2, and then region 3. So we've got 3 regions. There could be 2 regions. There's at least 2. There could be 3. There could be 4. Actually, as many as you need. This first one, this x value here is at -1, so it's x less than -1. It's the first part. This next one goes from -1 to +1.
yeah.
And then the third one goes from x greater than 1. Actually, it's kind of hard to see the third one because actually we don't know whether it stops or ends there. So there's actually could be either way, but not important at the moment. So one of the things students might do though for this first one, they're trying to draw the graph. I'm not saying you would do this, but they might think, oh, well, let me just extend the line here. Well, it's a little bit dangerous. I know we kind of did that in the previous problem, but you have to be really solid here. Like, see how this goes up 2 and over 1, up 2 over 1. We can assume that here that it goes up 2 and over 1. And that helps us with finding the b value, okay? Now we need the slope of this line. The slope of this line is, do you know?
2 over 1, so
2 over 1, so 2x plus. Where would it cross if it was extended? It looks like it would cross at 3. Now, how about this one right here? It's a horizontal line. Horizontal lines have the equation y equals a number. That number is whatever it is, and you just write it, that number here, which is 1. And then the next one here, you could do this and you say, okay, well, what if I was to extend that line? But that only works if you know the slope perfectly. So what is the slope here?
1 over 1.
So 1x. And then where would it cross? Looks like it would cross at 0. So you could say +0, or you just say 1x. Are your graphs more sophisticated than this that you're looking?
No, the ones on the quizzes and tests, she always asks graphs like this.
Okay. We can also, so let's do a few more. Let's do a few more. How is your comfort level with graphing these from the equations? Because that's another skill that might be asked.
Pretty good. Like, okay. Either way, it's not. I don't feel confident.
Okay, so let's do one more of these, and then I'll give you one, and we'll graph it, and that's really where most students struggle as well. So this one only has 2 regions, left and right. So the first one is good when x is less than or equal to 2. Why did I put a less than or equal to 2?
Closed circle.
Closed circle there. And then the other one is good when x is greater than 2. Okay, so now again, you're just finding the equation of this line. You want to find 2 nice points. Okay, down 2, right 1, down 2, right 1. So that's -2x, or -2 over 1x, plus, where does it cross? -1. Okay, now how about the other one? Can you try to figure out what that would be? What would the equation be? If I can zoom in if needed, but the slope is
-1.
-1. So -1x. And then that it's okay here to extend it because it's perfect. You don't have any, it doesn't not cross in a weird place. So what would the b value be?
So for these equations, we're just basically use the line equation to find.
Yes. Y equals mx plus b is the most common one. I mean, you can also use y minus y1 equals slope x minus x1. We haven't used it yet, but you would have to solve it for y. So you can't you can use either. This is where I don't know, the thinking of your instructor. If you had any pictures of tests or quizzes or homeworks, I could maybe help guide you down that path. But this is my best guess about what you want to work on. So I do see you sent some pictures. Those are logs. Okay, so we'll get to those. Let's do a graphing one. Here. Are you in person school right now?
No.
No. Okay. The reason I ask is, are you allowed to access like Desmos? And then do you know what that is?
We're not allowed to use notes. We have to keep our camera on. It's like taking
Okay. So it's a proctored lockdown thing. No fun. Okay. Because the reason I ask is because there are some better ways of there are some better ways of learning with access to tools on the internet. But if your instructor doesn't allow them, that doesn't matter. Okay. So this is a piecewise function. We're going to graph this. And this is what's generally hard. So there's three regions. You probably already know that. What I always do is I make a table for each one. It's a little bit different than graphing though. So we have x and we have y. So this number right here, this -2 is what goes here. And I say closed circle because I need to remember that because I'll probably forget. Now this means x is less than or equal to -2. That means I have to pick values that are smaller than x. And those are all smaller than x.
Okay.
Okay. Now there's a few things here. There's a lot here. What is the y value? Each of these, and it's whatever this is. So it's -4, -4, -4. And we already said this, whenever it's y equals a number, which is what it is here, what kind of a line is this?
Straight line.
It's a horizontal line. You got to be careful with saying straight because it could be vertical or horizontal. So this is a straight line. We're not, yeah, let me actually graph this. So I definitely recommend you graph as you go and not waiting till the end. This will apply in other classes. So -2, -4, closed circle. See, I was kind of hesitant because I forgot what it is there. -3, -4, -4, -4. This line goes this way because it ends here. We don't know how far it goes forever, but it ends here. And that's really what this piecewise thing means. So is that, did you follow that? If it didn't, I can explain it again. Give me some feedback, please.
That makes sense. That's
good. Great. Thank you. Okay, x and y, we're going to make another one here. Okay, so at -2, it's an open circle. And I got to go up to 2. So this is where you got to be careful. You don't go the wrong direction. It's between -2 and 2. So that's like -1, 0, 1, and 2. You generally go by 1. Okay. And then you definitely have to do the endpoints. Okay. You don't have to do all the intermediate points, but you definitely have to do the endpoints. So y here is x -2. So we're putting -2 into this. So that's -4. -1, -2. If you have time, if you have plenty of time on your exam, I would definitely recommend putting all the points in.
Okay.
All right, so now we're just going to graph them. -2, -4 is there. Now I know it says open, but we already filled it in. So whenever you have an overlap, I don't know, overlap, open, and closed, it's kind of like rock, paper, scissors. The the closed takes precedent. So,
Okay.
so you'd fill it in. Sometimes there's some confusion on that. -1, -3, 0, -2, 1, -1, 2, 0, but that's an open one. I like to make these really emphatic, like make it very clear that's an open circle. No, don't make it any mystery for your instructor. They don't want to have to wonder what you're doing there. All right,
Yeah.
last region. So x is greater than or equal to 2. I kind of messed up here. I didn't give us enough room. So, but it's x and y. You're starting at 2. That's a closed circle. Closed. Values bigger than 2. So like 2, 3, 4. With lines, you only need 2 points, but you can do as many as you feel comfortable with. So we're putting those x values into this right here. So 2 times -2 times 2 is -4 plus 4 is 0. -2 times 3 is 6. -6 plus 4 is -2. -2 times 4 is -8. You got it. So now we go to our graph. 2, 0, 2, 0. So now we're filling that in because we just had one that worked. 3, -2. Boom, right there. And then 4, -4. So right there, like that. You've got to have the arrows on the end because your instructor needs to know that it keeps going.
Okay.
Is this an example of something that you would see in class?
Yes.
Okay. Would it be more complicated than this? Meaning, would the functions be something different than lines?
I don't think we've had any. We've had it on homeworks, but she said that that's on tests,
Okay.
the final. So I think I'm good. Also, do you need to put like, so for the ones where it's just like x like greater than or equal to 2, do you need to put like an infinity there or like a negative infinity on
No,
the?
no. On the graph, no. You just show that it goes on forever.
Alright.
Same thing over here. If you stop it, you will be marked off. If you stop it, you'll be marked off. So you have to know that it's heading, and it's pretty straightforward. Like, see how this graph, see how the arrows go to the left, up and down. There's only 2 regions, so the outside regions are going to have that. This one is incorrect. There should be arrows here and here
Okay.
on it. The person didn't graph it right or whatever technology. Doesn't really matter. This one's correct. So there's an arrow. That's good. Okay. I'm going to suggest we transition to logarithms. And if we have some time at the end, we'll do this. If that's okay with you.
That's fine.
All right. So we're solving logarithmic equations is what I see in the first one here. I'm going to go through the examples and then we'll do some like the examples. So this is example 98.5 and it says log of x equals 3.
I just never know where to start with these problems.
Yeah. So you have to know how to undo log. Okay, so kind of off to the side here is some information. So like, let's say it's log base b of x equals a number. Okay, most of the time b is 10, so we can make a simplification here and say log base 10x equals a number. To undo this, you raise both sides to the power of 10. So it's 10 log base 10 of x equals 10 to the power of n. What this does on the left is it undoes the log. So x equals 10 to the n. So to summarize, you use 10 to undo log.
Okay.
But more generally, this is important, more generally, because you won't always get whatever it is. If you have log base b of x equals a number, you use b to undo log. It just so happens that it's always 10. So like here, this is 10. There's really a 10 here. So if you can undo the outer one, 10 log base 10 log x equals 10 to the third.
Okay.
Okay, so notice that undoes this part over here. So it just becomes log x equals 10 cubed. Now, do you know what 10 cubed is? It's 10 times 10 times 10,
Yeah.
which is 1,000. So again, there's really a 10 here. So you undo log with log base 10 of 10. So it's 10 to the log base 10 of x equals 10 to the 1,000 power.
Okay.
And that undoes this over here. So it just becomes x equals 10 to the 1,000 power, which is a pretty big number. That's why they just write it that way. So your book jumps into a problem that's a little bit too difficult. Let's just say it's log base 10 equals of x equals minus 2. How do you undo log base 10? Well, you use 10 as a base, 10 to the minus 2. So what a lot of students do is they forget to write this. You have to do it to both sides, just like solving an equation. Whenever you do one side, you have to do the other, one side, the other, so on. On the left side, it undoes this. So it's x equals 10 to the minus 2, which is 1 over 10 squared, which is 1 over 100, which is 0.01. Did you follow that?
Good. Thank you.
Okay, let's do one more here. I'm gonna have you do this one here and I'm gonna leave the previous one up. What is log base 10 x equals minus 3? I want you to solve for x, please.
So it would be x equals 1 over 1,000.
1 over 1,000. Great. Okay. Now what your book is doing, which is a little odd because you first need to know how to solve a single log. They're saying, well, what's the log of 2? Sorry, log of x equals 2. So to undo this outside one, the 10 isn't written. So when it's not written, it's 10. And so what a lot of students do, here's the shortcut. A lot of students will write log of x equals 10 squared. And what they're omitting is this step where you write 10 log x equals 10 squared. They're saying, I don't want to write this stuff on the left. I just want to write what it reduces to.
Yeah.
And then below it here, they do the same thing and say, okay, x equals 10 to the 10 squared.
Okay.
So that would be 10 to the 100 power. Okay, now we haven't done, I want to do a couple of these. Let's say it's log base 2 of log base 3 of x equals 1. Okay, so we've been using 10 to undo this, but what number should we use this time to undo the log?
2.
2. 2 to the log base 2, log base 3 of x equals 2 to the power of 1. So on the left side, this becomes log base 3 of x equals 2.
So then would we just undo log again with 3?
Yes, 3. So it'd be 3 log base 3 of x equals 3 to the power of 2.
Okay. And it would be 9.
It It would be 9, exactly. X equals 9. Okay, so let me take a look at this other example before I give you more. That's weird. Why did they do that? Okay, let me have you do one more before we move on to this. So let's say it's log base 4 of log of x equals 2. Let me have you solve this.
Would it be 10 to the 16th power?
Yes, very good. Okay, so now a new kind of problem. I want to actually solve something before we go back, before we do this next example. Let's say it's log of x squared equals 12. Okay, so there's a property that says if you have log of x to the n, this equals n times log x. So what this means is this n comes out front. So the exponent becomes a multiplier. And this is just a property of these things. Like we don't need to discuss why this works. You just need to know that if you have a number out in front, or I'm sorry, a number as an exponent, it goes out in front. Now, in the same way, you actually can bring if it's out in front, you can bring it here as an exponent. But like on the problem on the left here, this 2 comes out in front. So this becomes 2 times log of x equals 12. Is that okay? Like, did you at least follow that?
Yeah.
Okay. Now before we would just undo the log with base 10, but there wasn't a 2 in front. So we need to undo the 2 by dividing. Log of x equals 6. And then undo this with 10. So 10 to the log of x equals 10 to the power of 6. So x equals 10 to the power of 6. So if you understood that, and I think you did, try this one here. Log of x cubed equals 27.
X equals 10 to the 9th power.
Yes. X equals 10 to the 9th. Very good. Okay. So the problem, so that's pretty straightforward. The problem is that what happens with students is sometimes they forget log of x squared is not the same as log x squared. Okay, so the difference is that this on the left is really log x times log x, and the one on the right is the log of x squared. You have to be really careful about this because, and we'll just make up an example here. Let's say it's log x squared equals 4, and log, actually that's not it. Let's do, change this up here. 9, and let's go log x squared equals 9. So on the right, you know how to solve this one. You bring the 2 out in front. 2 log x equals 9. Divide by 2, divide by 2. Log x equals 4.5 or 9/2. So x equals 10 to the 4.5 power. On the left here, how do you undo a square? Do you recall? Square root.
Oh yeah, square root it.
So you square root it. Now when you square root something, it's plus or minus. Now that doesn't actually affect the answer, but it becomes log x equals 3, comma log x equals minus 3. Now how do you undo a log again? You use power base of 10. So this becomes x equals 10 cubed, x equals 10 to the minus 3. Are these the same?
No.
Nope. So this isn't a proof, but it's an example to show you that this is not the same up here. These are just examples of, or these are just, they're very different, and you have to just be careful what it is. I mean, so your example, I don't like the example in your book at all, but I think we have enough now to talk about it.
So which side would we start with? Like,
yeah, it's a great question. On the left side here, you can make this 2 log x. And on the right, this is log x times log x.
okay.
Okay. And the common mistake, it's a very common mistake, is you do not divide by log x. Like imagine this was 2x equals x times x. You don't do that. You actually move to one side. So we're going to move both of these over to the left, just my preference. So 2 log x minus log x times log x equals 0. And now you're going to factor out log x.
Okay.
So you have log x 2 minus log x equals 0. So this is very much like, oh, I have x and 2 minus x equals 0. I have to set both equal to 0. So set log x equal to 0, 2 minus log x equal to 0. Okay, now on the left here, you know how to do this. You use base 10, so x equals 10 to the 0 power, which is 1. On the right, though, we haven't really done one like this. You would add log x to both sides, so it's 2 equals log x. And we can just rewrite it here, log x equals 2. So you undo it with 10, so x equals 100.
That's a better way than what the book did.
Yes, yes. All right, so this actually takes us to the close of our lesson today. Lessons are about 50 minutes. So I'm going to send you a PDF copy of the notes and a link to the screen recording for today. And I apologize again for that issue with the spam. I am working on it, and I'll just if you do schedule again, just to check your spam folder until I get it worked out. Why it's doing that, still can't figure that out with Google. Thanks again for scheduling, and I'll see you next time.